All right, this next part should not be as like, I don't know what's going on because COVID is new. But here we'll talk more about like what we do know and some other stuff about toxicology. So we're going to finish up with conservation medicine and move into toxicology and chemical risk. So conservation medicine examines how environmental changes threaten the health of humans and natural communities. So conservation medicine really looks at like how changes in the environment are changing the health of the environment itself, but also the health of like humans. So, for example, we had a bad Zika year probably because of increased temperatures during winter. We have white nose syndrome in bats probably because it's a little bit warmer in the caves during hibernation, and so the fungus can grow. Now, in addition to that, this fungus seems to be relatively novel in most populations, so it's like new in those areas, but it can also like last in those areas because the fungus is not dying off. Antibiotic resistance is another thing we want to talk a little bit about because this is resistance caused by bacteria that are naturally evolving resistance and then passing it on. And it can be increased by people like either overusing antibiotics, so for example, taking antibiotics for the flu, or not completing their entire course of antibiotics, which means that then they end up having to take more later. And so then you get this antibiotic resistance. So here's an example. You have our bacterial colony. You use an antibiotic, most of them die, but you might have one with a slight mutation. That mutation is random, but it makes that bacteria resistant. And so what happens is then if you use the same antibiotic on that population that it was resistant to by this random mutation, now the entire colony has that gene. You can also get these drug-resistant things transferred in other ways. So here, maybe we have a harmless bacteria that is drug-resistant. So natural bacteria on your skin, but it's drug-resistant. And then it comes in contact with a harmful bacteria, and it can, by conjugation, transfer some of those genes. So now you have a harmful bacteria that is also drug-resistant due to that conjugation, so transferring that gene. Currently, about half of all prescriptions are for the wrong drug or are unnecessary. So they're prescribed for a virus because patients want the doctor to do something, even though the antibiotic won't help. Also, antibiotics are given in animal feed. So that can be a problem too because antibiotics given in animal feed, we have more of them in the environment. And actually, I'm going to stop and not go into the toxicology stuff because I think all of that stuff will be better in its own separate video.